So that's a pretty powerful idea, right? That conviction right there, that's coming from one of the minds behind ChatGPT. And it's the driving force behind his whole new mission. The idea is that for all the amazing stuff we've seen AI do with language and code, the real next giant leap, well, it isn't just about bits. It's about atoms. And that's exactly what we're digging into today. We're going to talk about how Liam Fettis, yep, a co-creator of ChatGPT, is now taking on one of the toughest problems out there in science. He's building an AI foundation lab, but not for language, for the physical world itself. His company is called Periodic Labs, and we're going to explore just how they plan on pulling this off. What we're seeing here is a huge shift, a really pivotal moment. For the last few years, all the buzz has been about AI that gets language, that can write and talk. But now, the frontier is moving. It's shifting from bits to atoms. We're talking about going from just digital smarts to an AI that can actually understand, predict, and maybe, eventually, manipulate the real physical world. And the person right in the middle of this whole thing is Liam Fadis. Think about his resume. He's worked on some of the most powerful language models ever at Google Brain, and then he was part of the team that literally changed the world with ChatGPT at OpenAI. Now he's kind of coming full circle back to his roots to solve a problem that's, well, a lot more tangible. And here's something really interesting, something you might have noticed. Fadis isn't some outlier. So many of the top people in AI actually started out in physics. Why is that? Well, he thinks it's because physics gives you this really principled, kind of hard-nosed way of looking at the world. It's the perfect mindset for digging into these huge foundational problems, whether you're talking about dark matter or deep learning. Okay, so to really get what Periodic Labs is all about, you kind of have to understand the journey that brought Liam Fettis to this point. It's a pretty fascinating path, so let's walk through it. Look at this career trajectory. It's wild. He starts out studying the most fundamental laws of the universe, literally searching for dark matter. Then, boom, he jumps over to Google Brain, right when the transformer architecture, the thing that makes all modern AI work, was being born. After that, he heads to OpenAI and helps turn the powerful GPT-4 model into the product we all know and use, ChatGPT. And now, he's bringing it all full circle, mashing together his deep knowledge of physics and AI to go after this totally new frontier. Okay, but here's the giant hurdle. Applying AI to the physical world is just fundamentally harder than applying it to language. And it all boils down to one critical thing: data. You can't just Google the physical world. And this next part really breaks down the core challenge they're up against. Think about it this way. Large language models had it, well, not easy, but they had the entire internet to learn from. That's a practically infinite library of everything humanity has ever written down. It's all there, ready to be scraped. But for the physical world, that data just doesn't exist in the same way. It's not just sitting there. You have to generate it through super expensive, super slow experiments and simulations. There's no giant, ready-made data set of how atoms work that you can just download. And here's the real kicker. Even the data we do have, from decades of scientific papers, it can be a total mess. Fettis talks about how for just one material property, the reported numbers in different papers were all over the place. We're talking orders of magnitude different. Now, what happens if you try to train an AI on that garbage? It learns noise, not facts, not the ground truth. And that leads to a crucial realization. You can't build the future on messy old data. You have to create your own clean, reliable data from scratch. So how on earth do you solve a data problem that big? Well, this is where Periodic Labs' big idea comes into play. This is their secret sauce. They're not just building an AI to analyze data, they're building a whole system to generate the data it needs. It's a completely new way of thinking about the scientific process. What they're building is this awesome thing called an interactive closed-loop system. The AI isn't just a passive observer here, it's right in the driver's seat of the scientific method. So check this out. Step 1, the AI designs a new experiment. Step 2, automated robots in a lab actually run that physical experiment. Step 3, the AI looks at the brand new data that just came out. And Step 4, it learns from those results and uses that knowledge to design an even better experiment for the next round. It's this incredible self-improving cycle of discovery happening super fast. And the way they've designed the AI for this is pretty ingenious. The best way to think about it is like a really smart project manager. They're using a big language model as the brain of the operation, the orchestration layer. This LLM can read all the scientific literature and kind of reason about the big picture. But then it calls on these smaller, super specialized AIs, like a toolbox full of expert tools. Each tool is an expert on one specific task or atomic system. So you get the best of both worlds, the broad general reasoning of a language model combined with the deep, focused power of specialized models. So, okay, let's step back for a second. If they actually pull this off, what does it mean? The implications are just staggering. Freitas doesn't see this as just another small step forward. He compares it to something like the agricultural revolution, a sudden, massive leap in human productivity. But this time, it's not for growing food. It's for building, well, everything in the physical world. And that leads to this huge, central question that's driving their whole company. What if our physical world could innovate as fast as our digital world? I mean, seriously, think about it. We've all seen how fast software and AI have been moving lately. It's unbelievable. Now, just imagine if we could bring a tiny fraction of that speed to discovering new materials for, better batteries, faster chips, stronger airplanes. It all leads to this grand vision, the company's ultimate mission. And their own words for it are kind of mind-blowing. They want to give humanity agency for atomic rearrangement. I know, it sounds like something straight out of science fiction, right? But what it really boils down to is the ability to design and create new kinds of matter on demand to solve whatever problems we're facing. And this isn't some abstract academic idea. The real-world applications are literally everywhere. We're talking about designing way more efficient semiconductors for all our gadgets, creating materials for aerospace that are lighter and stronger than anything we have today, discovering the perfect catalyst to make clean energy a reality. It could completely revolutionize the entire world of advanced manufacturing. Ultimately, what this technology is trying to do is give us a control panel for the atomic world. That's a profound change. We'd be shifting from just discovering materials that happen to exist to designing them from the ground up to do exactly what we want. And that leaves us with one last, really fascinating question to think about. If you lived in a world where matter was basically programmable, what would you create?